It's difficult to bring students to observe in situ testing. So, how can you bring in situ testing to students? Typical lab experiments allow students to engage with soil and get a feel for its properties in a hands-on way. But is a lecture the only way to teach students about in situ concepts?
Taking these cone resistance and friction ratio, utilizing the SBT index equation, then we can get to this soil behavior type profile.
With the GeoExplorer CPT operator module, students can engage in the same hands-on style of learning for in situ testing. Seeing the parameters collected in live time allows students to engage with soil properties just as they would in the field. Students can see the graphs presented in lecture in real life and link the concepts from the lecture to the concepts they see in the virtual lab. GeoExplorer also allows students to develop their understanding of important soil characteristics. Through gamification, students interact with varying cone resistance and friction ratio values to see how these variations affect the soil behavior type. Using Robertson's updated 2010 correlations for CPT data, students can see that, in general, soils with low tip resistance and high friction ratio behave like clayey soil, whereas soils with high tip resistance and low friction ratio behave like sandy soil. This allows students to develop the building blocks for a soil behavior type profile themselves. This gamification extends to students preparing to run the virtual CPT and navigating the virtual environment, much like they would in a traditional lab experiment or possibly in an internship. To further develop the pseudo-internship experience for students, the virtual reality of the game environment is masterfully paired with real-life company website for a mixed reality mock internship. Students can explore more of the context of the GeoExplorer experience through the Terra web pages and resources. The website is interactive and acts as a hub for the experience. The students can learn about not only the fictitious Terra company, but also more about the type of work that is relevant to in situ testing by navigating the site. Students take a pre-experience survey that serves as a baseline for the cutting-edge research being conducted from both the technical content and student motivation perspectives. This data has been used to update the environment to be more engaging for students. To further this link to real-life problems and engineering challenges, the 4 missions that students can experience in-game are contextualized on the website and in the game. Project Manager Maya Jones sets the scene for the site investigation that students must complete. Students use engineering judgment and the information they learned in the classroom to figure out how deep to run the cone penetration test and receive feedback on their choices. By participating in this research, you have the opportunity to join the community of educators committed to furthering our educational tools. This project promotes professional development for instructors looking to implement this module in their courses, and GeoExplorer aims to continually incorporate your feedback to make the experience better for yourself and your students. Please contact Dr. Victoria Bennett and Dr. Tarek Abdoun of Rensselaer Polytechnic Institute, Dr. Casper Hartveld of Northeastern University, or Dr. Zhenya Zastavker of Olin College of Engineering for more information about joining this project.